Okay, so I had, actually, before we get started with this, I wanted to make a slide for this and I didn't have time. I want to pick a day to do our party, if that's all right with everyone. So Johanna had a poll. It looked like we really kind of converged on Saturday, May 7th. Does that work for everybody?
For me, it does.
Yeah, that works for me.
Everybody on the call.
Yeah.
Yeah, I think that's 6. That's the biggest day, and it's all of us, and I think that's the best. And you can still host, Johanna?
Oh yeah, definitely. Yeah, what's a good time for everyone? Thinking afternoon sometime, like 4, early or later. I don't know.
4 is good for me.
Oh yeah.
Cool.
Awesome.
I will, so I think what we're going to do with the undergraduate poster winnings is we're actually just going to divvy them up via Venmo. Is that okay? So try to get everybody's info.
Yeah, I'll like do something in Slack. Just put your Venmo accounts, and I'll just send you the money when I get it.
Okay, and then I will pay for the party. So Johanna, if I can get you some money for supplies and stuff, just let me know.
Oh, all right. Yeah. Yeah, maybe we can talk a bit and like what exactly you want me to get. Yeah. Okay.
Okay. Alrighty, so yeah, this is going to be pretty short on my end today, unusually short. A couple of updates. One is the saga of trying to get the voxel-based print for the area around the stadium is not going great. So it sounds like the guy that runs the print lab said that some of the pieces were not attached, which I totally already knew. And he spent a bunch of time trying to fix the model, and I was hoping he would just like hit print. And the floating pieces I don't care about. Like I was going to just like analog delete them by like letting them print and not be connected. What I didn't know was that when that happens on a resin printer, he says that the print fails. So that means that we have to fix it digitally before we try to print it, which I guess I will do. I have some ideas on how to do that. Cloud Compare can actually run a thing called connected components. So it can figure out what's a piece. And so you can just find what's connected and then find everything else and throw it away. And then I can just give them that. So that should work. That should work fine. I ordered 2 of these actually, one for me and one for the lab. These are the stand for the GPSs. One of the things that you're supposed to do with GPS is you're supposed to keep it mounted away from a lot of the older electronics, especially the compass actually. So each of these not only has the GPS, but has a compass embedded in it. So I ordered one of these and this will go on the rebuilt Hexoon when we get to that. I found an interesting blog. This is, I don't even know who this person is. It could be a total crackpot. I have no idea. But Google News recommended this to me yesterday. And I read about half of this and I enjoyed it. This is Joe Morrison at Substack. So if you are interested in a geography remote sensing related Substack newsletter, here you go. I also worked on a big push this week. Basically, I'm really trying to get Colleen's thesis wrapped up. So trying to be really available to her to read things and make revisions and edits and things. And to Gunjan so that he can get his experiment out the door. And we're really close on that. He's been working on the PsychoPy side. I was trying to knock out some of the automated way of doing the shading so that it's just a couple lines of code of doing it. And so we made some progress there. This is a satellite-based thermal image of, I guess part of Atlanta. And then when you add the DSM shading, it looks like that. So it's like a whole different thing. I mean, this is like utterly incomprehensible. Just looks like blobs. And then when you add the context, like you can see everything. I really like how this turned out. You can see these like big footprints of these like big, what must be industrial sites, like showing up as red. You know, the forests coming in and showing up as blue. Like it's really clear, whereas the pattern here is just totally garbage, not useful. So yeah, I really like how this turned out. I also made a version of this. I should have included this, but I made an animation. Well, you know what? I think I put it on YouTube. I'll show it at the end. But one of the things that, oh, I'll just show it there. One of the things that you can really easily see is the impact of terrain on it. So let's see, oh, did they change this around? Where's my stuff? Not library.
Oh, you signed it. Oh yeah, you got it.
Should be. Here, your videos, perfect. So this was just a quick render of that, but overlaid on top of the terrain. And so the thing that I like about this is that you can really see like not only like these dense forest stands as like land cover, but also like they're in valley bottoms, a lot of them. So you get this like double effect, the terrain kind of pooling the cool air, but also the land cover impacting it as well. So, and then the other things done included automating the production of these like individual frames that Gunjan wants to show. So this was all automated. I didn't include this, and I meant to, but part of the way that this was done was with a new Matplotlib container called like a subplot mosaic editor or something that let you define the frame sizes. So this is 3 different frames, 1, 2, 3, and then it let me combine these in a really useful way. So I didn't know how to do that. I've made complex subplots before, but not in a way that I could manipulate to quite this extent. So that was a nice feature. And then this is the A to B. So I'm glad they all worked. Gunjan's been working on using CyclePy to run the experiment, which is by far the most common way of doing it. I'm a little bit put off by the amount of code that CyclePy generates. It's like 1,600 lines of code to generate. This is just like when he was running this one task. I was like, that's not necessary. So, so the way that it's done is, he can kind of design the experiment in this like GUI interface, and then it like renders the code out. So he doesn't have to code 1,600 lines, but like, anyway, I think we can do the same thing just using OpenCV. The hitch is that OpenCV doesn't automatically let you both full size and preserve the aspect ratio of an image. And I can't believe it doesn't do this by default. And like the code to do that is not like, this is the code to do it. So it's not hard. It's just, what's that?
Extra work.
It's just extra work. So I can like, this can be done when you generate the images, and then you wouldn't have to do this. So, I mean, I think maybe for the next experiment, this will be more necessary, or maybe using Matplotlib, because I don't know, or maybe he just gets comfortable with CyclePy. The other thing, and he's not here to talk about this, but the output file from CyclePy is also this like super unwieldy mess. He probably won't mind if I show what that looks like.
I saw the GUI side of CyclePy. It looked cool, but I didn't.
That part is neat. The GUI part is good. Like I'm totally happy with that. And he has learned it well. He's got it figured out and has got the stuff looping the way it should loop, and generating the data that he should generate. But let's see here. So this is my data. And what it ends up looking like is this like super messy spreadsheet of like discontinuous columns. That's not that's not ideal. You know, for the data analysis on the back end, like all this has to get cleaned up. So I don't know. I'm just, you know, CyclePy is good, but it also seems to have some drawbacks, and just interested in exploring other options.
Couldn't generating 3 different sheets be an option for the different tests?
That's what I think. Yeah, it just generates 6, but at some point,
Just looks like a big matrix.
yeah, that's I probably would have done this the 6. We were hoping to get CyclePy to just stick them all together. Like that also shouldn't be. It should be able to handle that.
Yeah.
I don't know. I mean, Gunjan's just learning the software, and I don't know much about it. You know, I coded like 2 things in it, so I just am not enough of an expert to know what it can do and what it can't do. So, oh well, but it's working, and he's got it laid out. He ran me yesterday. We found a couple of last little things that needed to be edited, but he's going to be looking for volunteers. So anybody that can, you've already done it once, but anybody that can just sort of sit down. The whole task takes, I think he said it took you 37 minutes. So, you know, less than an hour. It's not so critical that, you know, mostly it's just a matter of generating data at this point that works, and then we can like inspect it and make sure that like before we run real participants.
It's pretty fun.
It's pretty fun, yeah.
The survey where you ask yourself.
The other things that I did then this week are I finally got around to updating some of the wiki pages on the site. One is about color. This one's not done yet. I want to include some little bits about like how to choose color palettes better. I think that's the last big piece that I want to write that I haven't written. And then I wrote a thing on coordinate systems, projections, datums, ellipsoids, and geoids. This is stuff that I know I talk to people about. I presented in my classes, but I want to make sure that we have something that's like accessible. The only problem with this is I think, I don't know how, it might be overly technical. You know, I want to be precise at the one level, but also try to get an introduction to the concept. So people can read that and let me know what they think of it. It doesn't all have to make total sense, but you know, hopefully it's a good primer. So my goals last week were these. All I really care about are the first 2. The other 3 I'll do if I ever have time. So I'm not even going to mark them as red. It's just kind of like stretch goals. But yep, trying to help with the other things. Colleen and Gunjan are both at a critical point, so trying to get that stuff wrapped up. All right, Shashank.
What happened to your arm?
It was a bike accident. Yeah, I flipped over the handrails, hit the front brake a little too hard.
Really?
Yeah. It was it was a Saturday, and there was like a bunch of parents on campus, and there was somebody like a mom flagging me down like to ask for directions, but I was going pretty fast, and I took out my earbud with the wrong hand and braked with the left hand. So I only had one hand on the, you know, on the brake, and like I started to go forward, so I braked even harder and just flipped.
Oh gosh.
Yeah.
Did she feel bad?
Oh yeah. She was saying all kinds of stuff.
Like hit your face first, right?
Yeah, well, I think it was my shoulder actually, but I hit my head too. Yeah.
So
Were you wearing a helmet? No.
Cameron wearing a helmet.
I don't know if you have like a messenger bag, but when my arm was in a sling, I learned that it was much easier to deal with that.
Yeah, it's my collarbone, so I just try and keep it like still as much as possible.
The color scared me.
No.
The color.
Yeah, you saw it.
Shall I get started?
Yeah.
Yeah.
So this week I worked on a few things.
Ooh.
So I started working on reality capture.
We
That-
can't see it.
Oh, the screen share. Oh, no. Oh, I must have hit stop. I'm sorry.
So let's get started. So I started like using the images last time we captured of the lab and the grad office, and this was generated in reality capture. So there were like a bunch of options to find the product, bunch of extensions, and I ended up with the XYZ point cloud files, and these are the point cloud files that I generated from reality capture.
So these are images.
Yeah, the point cloud from images,
Okay.
and now I'm like working on if these could guide me to like align the live scans. That's what I'm looking for.
I see.
So last time we talked about like using the E57 in reality capture. So I think I've got an idea about like integrating those two together. But this is the file that this looks really good to me.
Yeah, it does. Yeah. I think that turned out better than the Pix4D one.
Yeah, and I've not done
Some
any.
shots look better.
Yeah, I think the animation did not go really well, but and even looking at the lab, I think this section of the walls, the whiteboard section of the walls is not very good.
Hmm.
But the walls are not very good in any of the walls. So the middle portion is really nice, I think.
TV's gone.
I think all the images were taken from the. So
Oh,
that may be the
yeah.
reason
Just
why.
to, well, even still, I think it does show up in the Pix4D version, but
I'm not sure.
it's interesting that it's just like,
A couple of things like near to the camera are gone. That was my first thing I saw. So this generated a really good dense cloud from reality capture, and I think this will be something that might help to like align the point cloud from Livebox. So next week I'm going to work on this. Also, last week we talked about NFrame Sure, and the license at the lab was not working, and I emailed them and they sent me a key that's valid for 14 days. So I started working with the same images that I just showed of the lab. And the thing about NFrame Sure is like in other softwares, we use the images directly, but in this we need an orientation file.
Yep.
And there are like a bunch of options to choose the orientation file. And one of the options was the result from the first step of Pix4D.
Yep.
And that's the Neil_scans_calibrate parameters. You can find it in this directory. So I use this, but the thing is this appeared. So I tried to use the same images to see the product from Shure and reality capture, but the license, the key they provided me does not let me work with
huh,
high megapixels images. So I'll be trying to do it again when our license is fixed.
wait, total image resolution sum. So that's the sum of each, like, that's a
I think they
12 per image or 20 per
Yeah.
image.
so they added
how-
all the pics.
So they added them
images,
all.
yeah. I think it's like the image count limit that I reached or something.
Yeah,
Yeah,
like
it
that
should be
times, oh, that's an interesting message. So your limit is 8,000.
Let me
If
know.
we were using, I don't remember which camera we used. Was it the 12 or was it the
Uh,
Hero 9 or the
The
8?
GoPro, I'm not sure.
I think it's GoPro 8 then. If it was
Okay, so
on
that's 12. Whatever 8,000 divided by 12 is. 7. That should be a lot of images though. That should be hundreds of images.
It's the images from all this whole lab, not just the lab, but the whole section of the corridor and the grad office.
Even still, that was only a couple of hundred.
Yeah, it was only like 200.
So this did not let me work with this. Everything worked until this step when I hit the play button and this appeared. So I tried like, is something wrong with the data set or is something wrong with like, did I not get something? So I did this. So the Pix4D data set that we have worked in the learning process.
Cool, yeah.
So these are the two things that I got, one from the Pix4D and the other is from NFrames. I'm not sure like are the results good or bad. The key difference in the ortho mosaic generated by NFrame Sure is like they generated multiple tiles.
Okay.
So you can see this margin, right?
Yeah.
So it's like a box, another box, another box. So this is not a single big file, but like multiple small files.
Okay.
And I'm not sure why this happened, but this section, these tiles seem to be having like, I don't know, brighter.
Hmm.
These are not very apparent in this. And even like in the like images next to it, I don't see why there's a sudden change. Something I did, I don't know. I realized that the Pix4D images, I don't think this looks really natural, but this looks like what it should be to me. I'm not sure.
Yeah, the left one might be, there's a checkbox in Pix4D for like color enhancing and
I
back
think
color
this is-
balance, so
yeah.
that's probably what's happened there.
And I think this is not, this looks more natural to me.
Yeah,
And I would love to try the NFRAMS thing with the image of the lab, but let's.
did you generate is there, I don't know, did you do meshes?
I'm not sure. I don't think I did.
So that's what I'm really interested in, the mesh difference. By, we were just talking about this in class today. I think that the N-frame Shure meshes
But
are supposedly a lot better. But that's kind of what I want to know.
I'll look onto it. The color information is the only key difference I saw,
Mhm.
and the boundary data set is like different for these images. I'm not sure what happened here. So that's all the work I did, and Dr. Pringle showed me this blog last week. So this talks about the MGRS coordinates in Python. So let's see what MGRS is. So MGRS is the military grade reference system that's very commonly available, but I'm not sure if I knew this before reading the blog. So the satellite imagery we use in this system, like all the bodies like Sentinel and stuff. These images are available in the MGRS system, and what MGRS is like, it is a system that's worked on the UTM system. So UTM is known by everybody. Everybody knows what UTM is, and the MGRS system is like a simplified version or a more detailed version of a UTM system. And this article talks about how it is related to UTM and what are the things we can do with the MGRS system. So talking about UTM, we know that UTM is like a plane coordinate grid system, and it is divided into like 60 strips, and each of these strips are given numbers. These strips are further divided into horizontal strips of 8 degrees, and these are given letters. So the number and the letter together represents a UTM zone. This is what UTM zones look like. So the strips I was talking about is like from here to here, there are like 60 strips, vertical strips, and these vertical strips are divided into 8-degree subsets, and each of these boxes are represented by a number with a letter together. So these are UTM zones. And these UTM zones are further divided in the MGRS system. So the UTM zones are divided into subdivisions of 100-kilometer tiles. So these 100-kilometer tiles are like subdivisions of UTM zones. So the UTM 17N is a zone we are very familiar with. MGRS system just adds like a couple of letters to it, and together these numbers and letters represent a 100-kilometer by 100-kilometer box. So the thing with this is like MGRS system as a definite way of representing a coordinate. So this is the system in which it represents a coordinate. So 3PWT and followed by a bunch of letters. So 3P is like 17N, which is the UTM zone. So it is a UTM tile of 3P. And the W2T is like, it is the name of the 100-kilometer box in the MGRS system. And a point is defined by two things. It's defined by a measurement from the left and a measurement from the bottom edge. So these the following numbers are like the distances from the left and the bottom. So this is what a coordinate looks like in the MGRS system. And to like relate UTM system and the MGRS system, I think this is the best way to see it. So 1P is like a box of a UTM zone. The UTM zone are further divided into boxes of 100 kilometers by 100 kilometers, and a pair of letters are given into it. So when I said something like 3PWT, what I meant was, so this is the 3P and WT should be somewhere around here. So looking at this box, what we can see is like this box is 100 by 100, but it does not totally fall on a single UTM zone. So that's the major challenge in the MGRS system. So I'll talk about this more. So in the MGRS system, we saw the very strange coordinate system it had, right? So to make it like generalized, we need to convert it to latitudes and longitudes. So converting this combination of letters and numbers into latitude longitude is the biggest challenge we are having. And one of the alternatives is finding MGRS shapefiles encoded with this type of coordinates. These are available, but I don't think we want to work with these shapefiles ever. So the other alternative is using something called like the MGRS library in Python. So a couple of examples are shown in the blog that I'm talking about. So it's just a simple library with a lot of methods in it. And MGRS is a very easy to use library, and example is shown is here, which converts latitude and longitude values to MGRS system. So it is a 2 MGRS simple method, and it returns MGRS coordinates for any latitude and longitude values. The actual thing we want to do is the reverse part, where we put MGRS coordinates into the latitude longitude parts. This looks very handy, but I'll talk about why this might not be as brilliant as we think it is. So here we are using the PyTorch library, and what it does is like it simply generates a geodetic reference, and for here we are using WGS84. And in this, we are using 2 lat long of the MGRS library, I think, which converts latitude, which finds out the lower left corner of the MGRS type. And all we need to do next is like find out the upper right box. We can just do it by adding 100 kilometers and 100 kilometers to it. So this is the idea of finding a particular coordinate system in the WGS84 system from MGRS system. But the thing is, when I talked about the a particular MGRS box not falling in a particular UTM zone, this might be the biggest challenge, because UTM tiles don't align perfectly with the MGRS tiles. So even like in this image, so when we are calculating the coordinates of anything in the 3PWT box, adding 100 might not give the exact coordinates we want. So this is the major challenge in the alternative shown in this block. So that's it from me. And like the goals next week are like my major goal is to work with E57 files in reality capture. And the other things are like working on more alternatives to generate high resolution and maybe in nFilmSure as well. So I'll be working with nFilmSure this week and possibly integrating it to S3 indoor mapping tools. So
Awesome.
yeah, and I found Kusheng Liu's playlist for learning Google Earth Engine.
Oh, nice.
And I think that's
Time well spent for sure.
Yeah, I think that's really good for me. So that's it.
So I've got a question about the MGRS stuff. So first of all, excellent overview. I appreciate that. I haven't taught MGRS since I used to teach maps and mapping back in the day, and we covered it in that. It's so rarely used with civilian stuff. I was curious, how often does the military even use this? That's question one.
Yeah, I saw some. I looked at a couple of videos, and this was generated for the militaries, but I didn't see like them developing it through time. So it was created and it has not been worked on since. I'm not sure if they're working on, but like the only recent applications are of like new satellite systems. They are embedding MGRS into the images. That's all.
Oh, wow. Okay. That's an interesting choice. I'll have to ask about that. And then the second question is, do MGRS coordinates only, that previous slide, number 9. Do they support sub-meter resolutions? If you just add an extra digit, does it just?
I'm not sure like if they can add precision, but they reduce precision by deducting like a few numbers from these.
Okay.
Does this?
That's weird.
Yeah. So I think that's because these were meant for satellite imagery, and I don't know, like they might not want like 100 kilometers divided into like 5-digit number. They thought they wouldn't have to like go even higher resolution. I think that's what they thought.
Okay.
When developing this.
Cool. Interesting. Well, thank you very much for the presentation. I appreciated that.
Sorry.
Cameron, you picking out some things you want to do?
I do.
One more week.
I want to do the GPS coordinates, and I'll get Lindsay hopefully to help me with that.
Okay.
I wouldn't mind firing up Google Earth, the VR again.
That's an easy
That
one.
was fun. I wanna.
Yep. And you can do it one-handed. You don't need both controllers. You can just use one.
Yeah.
Sounds good.
Maybe check out one more drone before I go.
Sounds good. You only have a week, so
Yeah,
pick your battles.
yeah.
Yeah.
I'll try and do the GPS because I want to be helpful.
Cool. I appreciate that. Thanks. All right, remote crowd, who wants to go next?
Is there any like training per se that I need? It's kind of fairly easy to.
Well, so Johanna, I had asked Cameron to maybe take the MLID Reach RS2 out to collect some what I wanted some ground control points around Blacksburg and Christiansburg, so like 20 spread out over the whole town of things that are like visible on a satellite photo. So like manhole covers or something, just kind of here and there. I'm sure you're really busy too. Do you have any time to, who else knows how to do that besides you and Andrea?
Yeah, Andrew was the only other one that I know. But yeah, I don't think it would take too long. I could give an overview and we could go somewhere near Wallace if you wanted to.
Okay.
That'd be
So
So
you-
just message me via Slack.
What was that?
Oh, sorry, message me via Slack and we can find a time that.
Okay, yeah.
So one of the tricks would be making sure that can you do a hotspot on your phone? So that his hotspot is enabled in the software, but otherwise it's just downloading an app and taking it out. So making sure that it's charged.
Mhm.
To do that before we leave today. Cool. Thank you, Johanna.
I unfortunately haven't been working on anything lab related, so I don't have anything to present this week. I've just been working on longitudinal camping study up at Annapolis Rocks and trying to get some writing done with that. And hopefully I'll have at least one paper ready to send out to a journal by the end of the semester. It seems like with Jeff now working with me on that, and hopefully we can get that done.
That's great.
Yeah.
Did you get a chance to try the log corruption? Did you at least run it?
Yes.
Did it work?
Yeah, it worked.
Oh, good.
So weird. Yeah, and yeah, I totally could have presented on that. I'll put that on my to-do list for, oh yeah, and there's like one other thing that I wanted to show the lab, which is how to do videos in Pix4D.
Oh yeah, that would be super useful.
Yeah, okay, I'll put that on, while that's not like project related, I'll put that on make that into a presentation for next week, I guess.
Cool. Great. Thanks.
Okay.
Oh, did you get a chance to, when you flew the drone, did you get to fly with the headset?
I was honestly too scared to do it. 'Cause I didn't know what was gonna happen. I was like, what if I crash this really expensive drone? So we mostly just flew around with someone wearing a headset.
Gotcha.
Yeah.
Colleen, quick update from you.
I am basically sprinting towards the finish line at this point. I've gotten a couple maps published, but they need to be redone. I've got essentially I got 10 tasks done and I have supposedly 10 left. So it's getting real close. And I'm gonna look over a couple of them today. And yeah, I'm getting there.
Getting close. Her thesis defense is going to be May 10th at 11 a.m., right?
Yeah, I got the room booked for it from Karen. So when you can ask Karen if the room's available and she'll just be like, oh, I can book it for you.
So, and then one of the hangups, Johanna, you might have an opinion on this. I'm not sure what is usually done with graduate students, and maybe we could like ask some of the people next door, but like, so it seems like Colleen has to have her thesis done to run it through an Authenticate report before she can schedule the defense. Does that sound right?
I don't think so. The authenticate. You know, I don't know if that's a new thing since I did my master's. Is that like just making sure that everything's cited and sourced and stuff like that?
Yeah. Yeah,
Yeah.
it's like turn it in, but I guess a little different.
I
'Cause I
mean,
didn't have to turn mine in until after I defended.
I wonder if Colleen, if we can, wherever we are, basically the gist is that you have to do that within like 12 days of whenever the thing is going to be. I don't know. We can work it out. But I was trying to see what. So I'm on 2 this time, and I think one of them was like not the final version, and everybody was just like, this is just an Authenticate thing. We got to cross this off the list. So like we uploaded whoever it was just uploaded wherever it was at that point. And it was like, same thing as you, Colleen. It was like 90% done, and then run it through Authenticate. So I don't know. We can figure that out.
Okay.
Alrighty. Well, thanks everybody. We'll wrap things up a little bit. We're not super early today, but good to see everybody. Have a nice weekend. Good luck as you kind of get into your final week of classes and whatnot.
Final.
Oh, real final.
If you survive.
All right. Colleen, you can stay on the line for just a second.
Yeah.
Okay. Bye, everybody.
Have a good one. Have a good weekend.
You too. Let me get the recording stopped here. Sometimes, there they are. Share. Stop recording.